So hello everyone. So today, I'll be going over the effects of exercise on BDNF levels in adolescents, and this is a systematic review with a meta-analysis. So for an introduction, for the overview, the teenage years are a big time for brain growth. The brain is rewiring, building new connections, and then developing skills like memory, focus, and decision making. During this time, the brain is very open to outside influences like exercise, sleep, and then daily habits. So one thing that helps the brain grow is a protein called BDNF, which is brain-derived neurotrophic factor. BDNF helps brain cells grow, make new connections, and then stay healthy. Exercise has been shown to raise BDNF levels in adults, which helps improve learning and memory, but we don't really know how much it helps or works with teenagers or adolescents. So again, the purpose of this meta-analysis was to see the goal of this study was to see if exercise can increase BDNF levels in teenagers or adolescents. The researchers wanted to figure out one, if exercise really boosted BNF during this stage of brain growth. Two, which types, amounts, and intensities of exercise work best. If BDNF could be a marker for better brain and learning health in teens or adolescents. And then again, learning this can help schools and sport programs use exercise support both physical and brain development during the teenage or adolescent years. Oh, uh, so going on to the flow chart. Here's a diagram of the flow chart, and then the next slide will be kind of talking about the methods of the flow chart. So the identification, so they researched 8 databases. A couple of them were PubMed, Scopus, and then Web of Science, etc. They found 2,900 articles at first. They removed 352 duplicates, leaving 2,548 articles. The second step was the screening process. So here they looked at the titles and abstracts of those 2,548 articles. They threw out the ones that clearly didn't fit the topic, and then this was left with 117 full text articles that they read carefully. So the third one was eligibility. So after they read the 117 papers in detail, most were removed because they didn't either include adolescents, BDNF, or weren't exercise studies. And then this left 6 studies that were fully met the criteria. And then, so again, they included these 6 final studies for the systematic review. And again, only 2 of them had enough data to be included in the meta-analysis. So here we have a picture of the results. So this is characteristics of the studies included. So here are the 6 studies that were included in the review. Most of the studies were from South Korea, and one was from Canada. And then the design of this, so they had a randomized controlled trial group and then a non-randomized controlled trial group. And then they found that the randomized controlled trials are considered stronger evidence. The participants, so the number of teens in each group and their average ages, you can see that over here in the chart. And then again, the overall age ranges were from 11 to 16 years. BMI. So over here in the chart, it shows the BMI. So this shows the average body mass index of each group. And then some groups were obese while some were normal weight. And then the training status. So this describes if they were sedentary or irregular active before starting. Most were not regular exercisers, which matters because new people that are new to exercise can have a bigger increase and then changes in BDNF. So the just continued. So this table here shows how each study was set up, what kind of exercise they used, what the control group did, and then whether exercise changed BDNF levels. So following up, so how long each study lasted and how many days per week they exercised. Also, that was included in this chart as range from 8 to 12 weeks. So this just kind of gives us an insight on the duration. And then again, they exercise 3 to 5 days a week. So the next bullet is intervention. So the type of intensity of exercise done by the experimental group is detailed and explained over here in the chart. So examples, so we have aerobic, we have resistance weight training, which is sets and reps. Aerobic was treadmill running, cycling. Um, then we have intensity levels, moderate to high, and then some studies tested multiple intensities side by side. For the control, what the control group did for comparison. So most had no structured exercises or just normal daily activities or stretching. Outcomes, they all measured BDNF levels in the blood. And then the main results. So this is going to be the most important column, which shows BDNF went up as well. So the forest plot and the meta-analysis results. So this graph here shows that exercise might potentially increase BDNF, especially at higher intensities, but overall the effect was small and not significant. It also shows how limited the evidence was because only two studies had enough data to be included in the meta-analysis. So the conclusion for this, going from most important to least. So exercise can raise BDNF levels in adolescence, which is important because BDNF supports brain growth, learning, and memory. Moderate to high intensity aerobic exercise showed the biggest increase, while low intensity and resistance only programs had mixed or no effects. The overall effect in the meta-analysis was small and not statistically significant enough, showing that the results are still inconsistent. So most of the included studies had small sample sizes and varied methods, or so the stronger studies are needed before making like a confirmed conclusion if BDNF truly works. So then connecting to other research phases. So this fits with larger bodies of research showing that physical activity improves brain function and mental health, especially during adolescence when the brain is still developing. It builds on evidence from adult studies and shows that teens may also still benefit from BDNF, especially at the cellular level from exercise. And then this connects the cellular phase, BDNF changes with cognitive and psychosocial outcomes seen in other studies. Just continuing on to the conclusion. So the practical applications. So schools and sports programs can use regular structured aerobic training. So again, here this says 20 to 60 minutes, 3 to 5 days a week. And then again, this is going to support students' brain health, learning, and academic performance. Tracking BDNF could be used in the future to see how well exercise programs truly help brain development. And then coaches, teachers, and health professionals should and can encourage exercise, not just for physical health, but for brain growth as well. Again, continuing on to the conclusion. So some strengths from this meta-analysis. This was the first big review looking at just exercise and BDNF in teens. It included different types of exercise like aerobic, resistance training, and then mixed workouts that include both aerobic and resistance training. So again, these studies followed clear research steps, so it was done carefully. It showed early signs that exercise might boost BDNF, which can help with brain growth. And then some studies tested different exercise intensities, so we can also see what works best there as well. Some weaknesses with this meta-analysis. There were only 6 studies, and 2 were used in the meta-analysis. Most groups were small, with less than 20 teens. The studies all used different types and lengths of workouts, so the results were hard to compare. And then again, almost all were from South Korea, so it might not apply to everyone. And then overall, the evidence is weak, and again, it's just not fully reliable yet. So my final conclusion for future studies, we should do more studies with more teens to make the results stronger and just more reliable, and then use the same workout plan for everybody so the studies can be compared better. Again, the studies that were used in this, a lot of the workout plans, the intensities weren't consistent. Not everyone was on the same program. The test different workout intensities like moderate versus high to see what works best. And then again, measure BDNF along with things like memory focus, and then learning to see if brain changes actually help thinking. So my personal take on this, again, since the article showed that moderate and high intensity aerobic exercise led to the biggest BDNF increases, again, I'd focus future studies on high school PE programs, just using short high intensity sessions like running, or we could even incorporate circuit workouts in that as well. And then again, because some groups with obese teens had the largest BDNF jumps, I would also include students with different fitness levels to see who benefits the most. Again, I think you could also track BDNF and school performance together. For example, checking if students who show higher BDNF gains also see improvements in focus, memory, or even grades after the program. Again, that was my meta-analysis. Thank you for listening.